Okay, here we go. This is still P2. Today we're going to do scientific notation.
Oh, that's all the
Oh my God, how do you spell scientific?
You don't even know how to spell science.
S-E-I, right? No,
I can't spell
S-E-S.
science either, so.
What? Science
Better research your
scientific. N-T-I-F-I-C.
Is that right?
Look on your board.
Oh, okay. Yeah, that's right. Okay. I don't know. I had a little time. I couldn't figure it out. Okay, and we're going to look at radical and exponential form. So we did that a little bit last year. I'll give you a hint when we get to that. I'll just give you a couple little examples of that and then let you practice. So, what is the purpose for scientific notation?
To put big numbers into a small number.
Okay, to make really big numbers manageable and
To work out.
and have fun, yeah. And really small numbers that are really big but really small. So we can write into scientific notation numbers that are 5 billion, trillion, million, trillion, and then 0.0000007, 8, 9, 10, 11, 12. So that's really not much of a number. But here's what you need to know about scientific notation. This first number here needs to be between 1 and 10. So it needs to be greater than 1, but less than 10. So that determines where you put your decimal point when we're writing a number into scientific notation. The exponent here tells you how many times you're going to move the decimal.
Right.
If it is a positive number, that means that the original number is a big number. If it's a negative number, it means the original number is a really small number or a decimal. So that tells you which way you're going to move your decimal point. So if I write this out of scientific notation, I have 3.14. I'm going to move this 6 places, and because it's positive, the number's going to get bigger. So that means I'm going to move the decimal to the right. So I would go 1, 2, 3, 4, 5, 6, and fill in with zeros. And then you get your big number.
Oh, Shad, that was funny.
Me too. Okay, what if, now I'm going to say that it's a negative. So that means I have 3, with my decimal right here, I should move that over a little bit, huh? 3.14. If I have a negative exponent, that means that this number was originally a small number, so I need to move this 6 this direction. Sorry. So you get 0.0000000341. Remember that? Yes? Okay, so let's write a couple in scientific notation. Let's look at 5, 4, 2, 0, 1, 0, 0, 0, 0, 0, 0, 0. Where is the decimal point in a number like this? At the end. Right here, it's right. We don't actually write the decimal when you write a whole number, but it is right here. Where do I need to move the decimal to write it into scientific notation? What? Okay, between 5 and 4. You only have one choice of where to move it. If you move it here, between the 4 and the 2, now you have 54, which is bigger than 10. If you move it here in front of 5, now you have 0.5, which is less than 1. So there's only one spot that you can move it to make this first number between 1 and 10. So you're going to write all of this as that number, 5.4201. You're going to write until you get to the rest of the zeros. And then we have to see how many times we have to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that going to be a positive 11 or a negative 11?
Positive.
Positive, because this is a big number. And that's not a 10, that's an 11. Oh dear. struggling today. Okay, I'm gonna give you guys one that you can do on your own. This one I'm gonna make a small number. So what does that mean about our decimal?
It's negative. Oh, no, it's still in between the 7 and 4.
Right. Okay, write this one in scientific notation, please.
My problem is I'm bad at counting.
Me too, obviously, and spelling today.
I'm really bad at spelling.
Well, not with me.
She can take care of herself, she's old enough.
I don't know.
Feel bad.
I'm bad at counting.
Okay, where am I putting the decimal for this one?
Between the 7 and 4.
Okay, so I'm gonna make this 7.42 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10, because this was a small number. Everybody remember this?
Oh, yeah. I got
Okay.
it wrong.
You did?
I counted.
You counted wrong? It's hard.
Yeah.
Counting is hard. Okay, the second part of our lesson today, which kind of goes into Monday's lesson, is talking about radicals. We're not even going to simplify radicals today. We're just going to write between radical form
An exponential.
and exponential form. And if you had me last year, you will remember that remember the tree that I drew on the board?
Oh.
Yeah.
The root of the tree. So if I have a radical, the cubed root of x, the root of this radical is 3. Where is the root on a tree? On the top of the tree or on the bottom of the tree?
Obviously the bottom.
The bottom of the tree. So the exponential form for this would be x to the 1/3 power, where the root of the radical is like the root of the tree. See?
I think I failed this.
So-
test.
Fancy? I doubt it.
I'm pretty sure this is the one that I actually did.
Well, I don't know why, because if you paid attention, you could do this.
I'm paying attention now.
Okay. Good idea. So what's this radical form written as an exponent? I'll get you started.
X to
It's
the
going to be x to the 1/4. The root of the radical is the denominator of our exponent. Okay, now I'm going to math it up just a little bit because we have something could happen with our numerator. Let's say I've got the 5th root of x to the 3rd. What power have these been raised to?
The 3x. 1, 4.
The first power. They didn't have a power. They just had a root.
I said 1.
I thought you said 4.
I said 1, and then you looked at me and said no.
I thought you said 4.
Well, then I said 4.
Oh my gosh, stop arguing with me. I'm sorry.
I'm
I
trying
can't
to
help
take
it that you
air
mumble.
out.
With in Google Classroom. Okay. Well, whatever it takes.
I said 1.
Whatever it takes. I've got a lot of followers in there, like 63 people.
Ooh.
I know.
That's
Watch
not
out.
right there.
Okay, now, what's the denominator going to be here?
The did.
The 5. So what do you suppose the 3 is?
Probably it goes on top.
The numerator. The power goes on top. So the power's on top, the root is on bottom.
Give me the whole.
You got this?
Yeah.
Okay. Today's homework's really easy. I was going to go over it in class, and then we didn't for some reason. Well, everybody started working on other homework, so I just let them do that.
Okay.
So we'll start with this on Monday, but you guys should be able to finish this in no time. There you go.
Oh.
I think you need to make it bigger.
16? Yeah.
16, yeah. More homework?
Yeah, well,